We will get started in about 3 minutes. Hello and welcome to Data Analysis with Python 0 to Pandas. This is a free online course being offered in collaboration by Jovian.ml and FreeCodeCamp. This is a 6-week course. We started on the 15th of August 2020 and we have lectures every Saturdays. So today is the 4th lecture. We have lectures from 9 p.m. to 11 p.m. IST. You can earn a certification for this course and we are running this course in both English and Hindi. I'm your instructor Akash. I am the CEO and co-founder of Jovian.ml and you can find me on Twitter at AkashNS. And Jovian.ml is a sharing and collaboration platform for data science which we have been using to share all the materials with you during the course. And freecodecamp.org is a place where you can learn to code for free by building great projects and interacting with a worldwide community. A quick overview of the course if you're joining us for the first time. This is a coding first introduction to data analysis with Python, and we have video lectures with live coding on cloud-based Jupyter notebooks, which you can find in the description and follow along either with the lecture or afterwards. And we also have weekly assignments and a course project for you to practice the concepts that you learn and earn a certificate free of cost. The course website is 0topandas.com. A quick announcements for those who are joining us week by week. So assignment 1, the first assignment for this course is due today in about 10 hours. So if you do get a chance, if you're just joining right now, or if you haven't completed it, please try to complete it today. The details are on the course website. And assignment 2, the deadline has been extended to the 12th of September, next Saturday. And I'm really excited to share that the course lecture videos have crossed over 200,000 views, and there are more than 3,500 forum discussion posts. So do check out the course forum if you have not already. So the topic for today is analyzing tabular data with pandas, which is one of the libraries that we are exploring in this journey towards data analysis. So let's get started. So the first thing you should do is go to the course page 0topandas.com. And on the course page, if you haven't enrolled already, you will be able to enroll to be able to watch the lectures and submit the assignments. And if you're already enrolled, you can share this course with your friends and colleagues. As I said, today is the last day to enroll, and today is also the deadline for assignment 1. So here you see assignment 1. You can open it and follow the instructions to get started. It should only take about an hour to complete. Putting that aside, so you can find the videos from the previous lessons. So lessons 1, 2, 3 here on the specific sections, and also assignment 2, which is due next week. But today we are looking at lesson 4, analyzing tabular data with pandas. So we just click the open link here, and that will bring you to the lesson page. Here you will be able to see the lesson video. You can watch it live, or you can watch a recording later. And there's also a version in Hindi if you want to follow on Hindi. And you will find the links to the notebooks and the discussion forum here. So the notebook that we are going to use today is called Analyzing Tabular Data with Pandas. So you can click through and open this notebook. So this is a notebook, a Jupyter notebook hosted on the Jovian.ml platform, just as we've been using this for other lectures. And the first thing you should do, and please don't do it right now. Right now you can just watch the lecture, but later on you can click run and click run on Binder. And when you do this, we will take this notebook and run it on an online platform called Binder Hub. And it might take a few minutes to start up for you, but please wait for a few minutes and it should start up just fine. And if you have questions during the lesson right now or afterwards, you can ask questions on the discussion forum. So the link is provided here. You will find the discussion forum here, lecture 4, analyzing tabular data with pandas, on the Jovian.ml forum. And you can simply hit the reply button. So there is a blue reply button you will find at the bottom right. You can simply ask a question here. And if you see a question that you like, that you also have, you can click the like button, and we will pick the questions that are the most liked and answer them during the session. And we also have office hours during the week where we will be answering most of the other questions as well. So going back to the lecture notebook, I have clicked the run button and I have selected run on Binder. And now that has opened up this Jupyter notebook interface. This is where we will be doing all of our coding and we will be executing the code. So I'm just going to open up this specific notebook, Python pandas data analysis. And the first thing that I like to do just before starting any tutorial from an existing Jupyter notebook is to go kernel, restart and clear output. So this clears all the outputs so that we can now execute the cells, execute the code and view the outputs from scratch. And I will also do a view toggle header and view toggle toolbar so that you can see things a little better. But you can keep the toolbar around. It has many useful functions. Okay. So as we've been going along this journey, we've done a lot of things. We've learned some basics of Python and Jupyter. We've also done a quick tour of variables and data types in Python. And then we looked at branching using conditional statements and loops. And all of these, you got a chance to try them out in the first assignment. Then we looked at writing reusable code using functions, reading and writing from files, and numerical computing with NumPy. Now, all of these topics are available in the previous lectures, so you can go watch these videos, and you can also test out your skills after watching these videos by doing the assignments. Today, we are looking at analyzing tabular data with pandas. Now, we are running this code on an online platform, Binder Hub, and that is why we use the run button on Jovian. But you can also run this on your computer locally, and the instructions are given here. The instructions might vary slightly based on your operating system and the version of Python that you're using, but you should be able to follow along with this quite easily. Okay, so pandas is typically used for working with tabular data. And when I say tabular data, you can think of the data stored in a spreadsheet or in a database table. And the first thing that you might want to do is to actually read a data file into the Jupyter notebook using pandas. And pandas provides many helper functions to read data from various file formats like CSVs, Excel, spreadsheets, HTML, JSON, and many more. But the most common format by far what I've seen is the CSV format. So let's download a file Italy COVID daywise.csv, which contains the day-wise COVID data for Italy in this format. So, and we're using COVID data because this is something like we are right now in the middle of a pandemic, and it is a real tragedy. And there is a lot of information floating around. Some of it is right and some of it is just wrong. So what I wanted to help you with is to look at the raw data, analyze the raw data and make your own inferences, and also know what are the shortcomings in the raw data. So any headline that you read or any metric that you see, you should be taking it with a grain of salt and trying to verify it on your own. If you're suffering from the coronavirus or know somebody who is, our best wishes are with you. So this is the format and we have the data for Italy here. So let's download the file and we will look at it. So to download a file, we will be using the URL retrieve function from the urllib.request module. So this is the urllib.request module, and from it we import URL retrieve. And this is the URL from where you can download the file. So we pass the URL and then we also pass a file name where we want to download the file. So we want to download it into the current directory with the name Italy COVID daywise.csv. So let's run it now. And the file has been downloaded. Now, if you want to see the downloaded file, you can click File, Open, and you will be able to see here that earlier we did not have Italy COVID daywise, but now we have it. Let's give it a second to show the file. Okay, so while it loads, the format of the file is something like this. So the first row the first line contains headers or column names. So we have the date, we have new cases, new deaths, and new tests. And then we have day-wise data. So this is, each line represents the data for one day. So this starts from, let's say, the 21st of April. The number of new cases was 2,256. The number of new deaths was 454, and the number of new tests was 28,095. And this is the format in which you have the data for a bunch of different days. Okay, this file is loaded. So you can see here, date, new cases, new deaths, and new tests. And then you have the data starting from the 31st of December and day-wise data going all the way up to the 3rd of September. So just a couple of days ago. And this is only the new cases and deaths and tests daily for Italy. Okay. And this is called the comma separated value format because the values are separated by commas. All right. So to read this file, we can use the read CSV method from pandas, and it's a really simple method. So before that, we need to import pandas, and the pandas library by convention is typically imported using the alias PD, so that you do not have to write pandas each time. So once you've imported pandas as PD, then you can create, well, we call pd.read CSV and then pass in the file name or the full file path, and that returns what we call a data frame. So that's why we're calling it COVID_df. So df is a suffix just indicating that this is a data frame. And data frame is, so the data from the file is read and stored in a data frame object, which is the core data structure in pandas for storing and working with tabular data. Now we typically use the df suffix to identify data frames, but you don't have to. And if you check the type of COVID_df, it has the type pandas.core.frame. So this is the module where this class lives, and it is an object of the type of the class data frame. And let's take a look at this data frame. What exactly does it look like? So once we run this cell, we see that it looks like a table. So very much like a database table or a spreadsheet, and looks like there are some columns, the same columns that we just saw, and there are some rows. And there seem to be 248 rows and 4 columns. And as we've seen, this provides 4 day-wise counts, and the metrics reported are new cases, deaths, and tests, and the data is provided for 248 days from December 12th to September 3rd. Now, one thing to keep in mind is that these are officially reported numbers, and it's possible that the actual number of cases and deaths may be far higher, because not all cases are diagnosed and not all cases are reported, right? So you should not take this information to assume that we have a full list of all the cases. And now we can view some basic information about the data frame using the info method. So if you call coviddf.info, we will get some information like the list of columns. So the columns are, as we've seen already, date, new cases, deaths, and tests on a daily basis. And it seems like if you just see the non-null counts, then there are 248 values each for the first 3 columns. But new tests, there seem to be some null values. So if you see here, you will see nan, and this nan indicates that there was no value provided in the file for that specific on that specific date for this specific column, right? And it's different from 0 because 0 indicates that the value 0 was provided. So that's an important distinction. So that's some basic information, and you can see that it has, you see the number of entries, you can see the data types that are available. Now the date column seems to have the object data type. So object is the generic data type whenever pandas cannot really figure out what type of data is there in a particular column. And the rest of them, it has figured out that these are floating point numbers. Now, one other thing that you can do just to get a quick overview of the numeric data is to call the describe method. Now, if you call coviddf.describe, for each of the numeric columns, cases, deaths, and tests, you will get back the total count of non-null entries. You will get back the mean or the average. So it seems like the average number of cases per day was 1094. But if you check the standard deviation, it seems like the standard deviation is about 1500. So that means it's a very high deviation, and that's expected because this graph, initially it was close to 0. So during January, there were basically no cases on a daily basis, but during March, the caseload was really high, and then the caseload went down again. So that's why the standard deviation is very high. So the mean by itself is not very useful. And there are a few other metrics as well that you can look at. It seems like the maximum number of cases on a specific day was 6,557. That's pretty high. Now the column property of the data frame will contain the list of columns. So you can call coviddf.columns, and that will give you the list of columns in the data frame. And then you can also retrieve the number of rows and columns as a tuple using the shape method. So these are all different ways to get some meta information about the data frame. So we have looked at info, which is a basic information about rows, columns, and data types. Then we have describe, which has statistical information about the numeric columns. Then we have columns to get the list of column names, and shape to get the number of rows and columns as a tuple. Apart from that, we've seen how to read data from a CSV, but apart from read CSV, you have read SQL files, you can read Excel files, you can read JSON files, and a lot many different formats. Okay. So before we move forward, let us save our notebook because we are running this on an online platform, Binder, and this if you leave this tab idle for some time, this Jupyter notebook may shut down and you may lose your work. So I'm just going to install the Jovian Python library, and then I'm going to import it and run jovian.commit. And what this does is this asks me for an API key, which I can get from my Jovian profile after logging in. And after logging in, I can copy my API key by clicking the API key button here, and then I can paste it here and hit enter. What this does is this captures this notebook running on Binder, and this takes a snapshot and it puts the snapshot on my Jovian profile so that I can access, I don't lose my work even if this server shuts down. And later what you can do is you can come back and you can run on Binder again from this notebook on your profile. So every time you do some significant work, just keep committing your notebook to Jovian. Okay, so moving right ahead. So now the first thing that we might want to do once we have loaded up this data, the coviddf data frame, is to retrieve some of the data from this data frame. So for instance, we might want to know what is the count of new cases on a specific day, let's say the 4th of April, right? So a specific value within a specific column and a row. Now to do this, it might help to understand what the internal representation of data in a data frame looks like. So conceptually, you can think of a data frame as a dictionary of lists. So you can think of a data frame as having a structure like this, that the COVID DF data frame is similar in structure to this COVID data dict, which is a dictionary. And then this dictionary contains the keys. The keys are the names of the columns, column headers. And then the values of those keys are lists or arrays containing the values in those columns, right? So it's a little bit flipped from what you might be used to, but this analogy is helpful to think about pandas data frames. Now, obviously it is not an actual dictionary, and inside it you do not have actual arrays, because internally pandas is implemented in C++ using a bunch of other libraries. So it uses some other internal data structures, but this is the conceptual picture that you should have in mind. Now, representing this data in this format has a few benefits, and that is why pandas does it. Now, the one thing is that all the values in the column typically have the same type of, the same data type. So it's more efficient to store them in a single array. That's one thing. The second thing is that retrieving the values for a particular row, let's say we want to know what were the values in the 4th row. So we simply can fetch the 4th element from each column. So that is simply an array indexing, which is very efficient, especially when the data types are all the same. So that's a very efficient operation. So fetching the information for a row becomes very efficient. And then finally, the representation is a more compact compared to other formats. So another format that you can think of is that we actually use a list of dictionaries, where we have a list, and then inside each list, each row is represented as a dictionary, which contains the date, new cases, new deaths, and new tests. Now this will take up a lot more space because we are repeating the column names for every single row. And this will also not be as performant. On the other hand, this takes up far less space and is a lot more performant. All right. So keep this picture in mind as we try to retrieve data from this pandas data frame. I personally struggled a lot initially because I did not see this picture, and I would often wonder how exactly do you get data out of a data frame. Okay. So this is not the picture that you should have. This is not how pandas stores it, and this is the format how pandas actually stores data, conceptually at least. Okay, so now with this analogy in mind, we can now guess how we might be able to retrieve data from the data frame. So the first thing that we might be able to do is, well, let's see the data frame once again. So this is the data frame here. So the first thing that we might be able to do for the data dictionary that we created for the analogy, we know that the keys are column names. So accessing a key using the indexing notation gives us all the values, all the list of values in a column. So we can do the same here. We can index into COVID DF for new cases. And you see here, you can see that we have all the values. So starting with a bunch of zeros and going down to these numbers. And you can verify that these numbers match with the numbers shown here, right? So we have been able to retrieve a full list of values in a particular column. Okay. And now each column is actually, it's not really a list or an array, but each column is represented using a data structure called a series, which is essentially a NumPy array, but it has some extra methods and properties associated with it. So if you check the type of COVID DF new cases, you will find that it has the type series. And just like arrays, you can retrieve a specific value within the series using the indexing notation. So this gives us a series, and then out of the series we can get the value at the 246th index. So you can see that it has a specific index that is listed here. So 246 is the value is 975. So there you go, you get the value 975. And similarly, if you go in, let's say 243, you will get the value for new tests, you will get the value 53541. Again, we can verify this by going up. So 243, you can see that the data for new tests is 53541. All right. So that's how you can dig in. You can go find a column using the index, and then you can index into the column. So which is a series, you can index into it by passing the index of the row now that you want to access. Okay. Now this is a little bit inconvenient. So pandas also provides a helpful @ method. And the at method can be used to directly retrieve the value at a specific row and column. Okay, so you can simply say covid.at. Now here you need to specify the row first, which can sometimes feel more natural. So at the row 246, and then the column is new cases, and you get back the same value 975. And we can check at the row 243 and new tests, and we get back the same value 53,541. Okay. So instead of using the indexing notation, apart from what we've seen already, Pandas also allows accessing columns as properties of the data frame using the dot notation. So here what you can also do is you can say COVID-DF instead of saying COVID-DF. So this is the same as saying COVID-DF and then using the indexing notation. So instead of doing that, you can simply say COVID-DF dot new cases. So this is a slightly easier to write. It saves you a few keystrokes, and it also, what you can also do is you can just type COVID-DF dot and then start typing N and press the tab character, and that will auto complete the column names for you. So this is a good way to just explore the columns and other properties of a data frame. So that's one other way to access a column. Apart from that, what you can also do if you want to access multiple columns together, so you can pass in, instead of a single column, you can pass in a list of columns into the indexing notation to access like what is called a subset of the data frame with just the given columns. So here, notice this double bracket here. So the first bracket is for the indexing notation. And now instead of saying just a single date, we can simply pass in a full list of columns, and passing in that list of columns is going to give us a smaller data frame with just those columns. So now we have the date and we have the new cases right here. Okay. Now one thing to note here is that this cases data frame, the data frame that we just created right now, it is simply a view of the original data frame. So that means they both point to the same data. So if you were to somehow modify the information here at this location, or you were to modify it in the original data frame, so modifying in one would make the change in the other one as well, right? So because they're pointing to the same data in memory. And this is a very important thing to understand, because this is what makes Pandas really, really fast, especially when you're working with tens of thousands or millions of rows of data. So Pandas you can keep creating new data frames, you can keep generating new columns, you can keep processing this data without having to worry about repeatedly copying the data over and over, right? So that is slow and that takes up a lot of memory, but you do not need to worry about it at all. But the downside of that is if you change something inside one data frame, all the other data frames which are derived from it will also change. However, in the cases where you do need a full copy, and you normally don't, but in case you do need a full copy, all you need to do is just call the copy method. So if I create COVID-DF copy as COVID-DF.copy, then the data stored within this new data frame is completely separate from the COVID-DF data frame. So modifying the values inside one will not affect another. All right. So to access a specific row, we've looked at how to access columns. We've looked at how to access specific elements, but to access a specific row, you can use the .loc method. So the .loc method actually requires indexing. So here we have the data frame once again, and let us try to access this row of data. So you need to pass in this index 243 into .loc. So notice it's not a method. It's more of like you need to use the indexing notation here. So we say COVID-DF.loc, pass in 243, and then we get back new cases, new deaths, and new tests. And you can verify that this data matches what we see here. And each retrieved row is also a series object. So this is also a series, just like each retrieved column. So that's about getting a single row, but then you can also get multiple rows out of the data, and sometimes it might help to just look at just the first 5 or 10 rows, or maybe just the last 5 or 10 rows. Then to get the first few rows, you simply use the head method. So here we are trying to get the first 5 rows. You can see these are the first 5 rows, the first few days of January, and then you can also see the last few rows. So you can use tail for that. And here you can see the data for the last few days of August and then the first few days of September. All right. Now, one thing you might notice here is, and this is something that we mentioned earlier, is that some values are 0 and some values are nan. And how do you check No, the reason this happens is because this column does not have any information in the data file. So if we open up the data file again, so this is the file italycovid.daywise.txt. And if you check here that initially there are only two numbers available. So you have the date, new cases, new deaths, but there's no data available for new tests. All right. And then after a few days, after about 2 or 3 months, you start seeing data for new tests. So this is an important thing to understand. And this so what Pandas does, whenever it does not find a value within a CSV file or any other file, whenever it sees a blank value, it inserts the nan value there. So you can just check it out. So if we just try to access the 0th row, or we try to access this last element here, so row 0 and column new tests, you can see that the value is nan. And if you check its type, it's actually a floating point number. So it's a floating point number, but it is not really a number. It is, in fact, nan stands for not a number. So whenever and it is different from 0, and that's an important distinction to understand, that in this data set, it represents that the daily test numbers were not reported on specific dates. And that is why you have the number nan here. And if you find out, if you look it up online, you will find that Italy started sharing or reporting daily tests only after April 19th, 2020. And before that time, 935,310 tests had already been conducted, right? So this is some additional information that is not present in the CSV. And this is something that we should know beforehand while we are performing any operations, so that we account for this as well. Okay. So when you see a bunch of nans in a column, for instance, the column like new tests, the first thing that you might want to do is just identify where do the first valid indices begin, right? So you can check that by simply getting the series. So COVID-df.new tests and calling a .first valid index on the series. And here it tells you that the first valid index is 111. And now once you've gotten the first valid index, it might help to look at a few rows before and after this index, just to verify that the values are indeed changing from nan to the actual numbers. So if we call coviddf.loc with 108 to 113, so now we see a range of rows instead of a single row. And you can see here that around 19th April was the last day when there were no daily tests reported. And then from the 20th of April, we started seeing a daily test number. Okay. So that's about accessing rows of a data frame. Now, one last method I want to talk about is the sample method, which can be used to retrieve a random sample of rows from the data frame. So it's good to look at the first few, last few, maybe a slice in between. But what might really help to get a sense of the data, to see what kind of values are in there, is just to go through sample rows, randomly picked rows. And I often tend to do this 5 or 10 times with a sample size of 10 or 20, just to get a feel for the data and the feel for the range of numbers, see which ones have nan values, which ones do not. And of course, it's not perfect, but it is something just to get a visual understanding of the data. Okay. Now, one thing to also notice here is that while we get this sample out, you can see that the original indices of those rows are still retained. And that's a very useful thing. In fact, that makes Pandas a lot more useful than just a NumPy array, where if you took a random sample, you wouldn't know where those elements came from. But here you also know that, okay, we've gotten the 151st element, and then we have the 88th element, and so on. So that when we want to refer back to the original data frame, we know what to do. All right. So that is how you can get data out of the data frame. You can get columns. So to retrieve columns, you use the indexing notation. You can get out of a series or out of a column, you can get values out by passing in the index. So a series is just like a NumPy array. And then if you want to just get it directly out of the data frame, just get a single value, you simply use the at method and give it an index of a row and a column. And if you want to create a copy, if you want to get a single row, you use the .loc method. The LOC method, again, you have to index into it. And then if you want to create a copy of a data frame, you use the copy method. And then you have the head, tail, and sample methods to retrieve multiple rows of data from a data frame, right? So the thing here that you need to understand is that whichever way you want to access data out of a Pandas data frame, there is a way to do it. Now you may not always remember this, and you don't have to, but you can always look it up. So suppose you want to figure out how do you access a particular row of a data frame. All you need to do is take this expression, or just type out this expression into a search engine, how to access a specific row from a data frame. And that will lead you either to the documentation or an answer somewhere on a site like Stack Overflow, where you can find the syntax. And that is a perfectly valid way of going about this, right? And as you keep doing this over time, you tend to start remembering some of these methods. But honestly, I still tend to look up a lot of these methods, even though I've been using pandas for many, many years now. So moving ahead, let us now start analyzing the data from the data frames. We've created the data frame, we've accessed some values, and let us try to answer some questions about our data. So the simplest questions you might want to ask once you have this data is, what is the total number of reported cases and reported deaths related to COVID-19 in Italy, right? And I say related because not all of these deaths may have been due to COVID-19 alone. In fact, in a lot of cases, there are comorbidities. So that's again another detail to keep in mind, that to say that the disease has killed that many people is not completely accurate, although it is definitely a contributing factor. And these are all these things when you're doing your data analysis with the raw data, these are all these things that you really understand, which are sometimes not conveyed, subtle details that are not conveyed in the headlines or the reports that you see. So now we have the COVID data frame, and out of which we get back the new cases, and then on the new cases we call .sum. So this is, the .sum method is similar to the .sum method in NumPy, and you can call it on a series to get the sum of all the elements in that series or that column. So we will have the total cases and we get back the total deaths, and then we can simply print it out. So it seems like the total cases, number of reported cases is 271,515, and the total number of reported deaths is 35,497. So that's the data we have on Italy so far till about the first week of September. We might want to know, okay, what is the overall reported death rate, which is the ratio of reported deaths to reported cases. So that is simply, well, this sum, the total number of deaths reported by the total number of cases, and you can see that that is about 13%. Now that does not mean that 13% of people who contract the virus are going to suffer or die from it. In fact, the number is actually far lower, but we have to keep in mind the subtle detail here that not a lot of cases are actually asymptomatic, and then a lot of cases may never even get diagnosed because the person may not feel sick enough to actually come to the hospital, or they may come to the hospital and not find a test on a particular day. Then let's look at what is the overall number of tests conducted. And here we have to remember that daily test data was not being reported till a particular date, and a total of 935,310 tests were conducted before the daily test numbers were reported. So let us use that and let us incorporate that. So here we are saying that the initial tests were 900, was this number, and then so the total test becomes the initial tests plus COVID-DF dot new tests and .sum, right? So this is the sum of all the data in the new tests column. And when we're taking a sum on a series, the nan values get ignored. This is just something to remember with pandas, that nan values will always get ignored, and while aggregating. And then the initial tests, we are adding that. So that gives us the total number of tests, which is about 5.2 million. All right. Then we have, we might want to find out what fraction of tests returned a positive result. So it turns out that the positive rate of total cases by total tests, that was about 5.21%, right? So about 5.21% of the tests in Italy led to a positive diagnosis. Now this value may actually have varied month from month, and we are only looking at the overall value here. So this is how we can answer some basic questions about our data. Now at this point, you might want to try asking some more questions about the data, and you can use these empty cells to first, and this is how you actually go about analyzing a data set. The first thing you have to do before you even do any analysis or write some code is just to ask what are the questions you want to answer from the data. And I'm sure as you've seen this data, as you've looked at the things we are doing, you may have many other questions. So try them out here. And that's the best way to learn the pandas library as a whole and data analysis in general. And from time to time, I'm just committing and saving my work so that if this binder instance shuts down, I can resume my work by just clicking the run button from Jovian. Okay. So now let's look at querying and sorting rows of data. So let's say we want to only look at the days which had more than 1,000 reported cases, right? Or we want to look at the or we want to look at the days which had less than 100 cases, and we can have many other criteria like this. So to do that, what we can do is we can use a Boolean expression to check which rows satisfy this criterion, which is more than 1,000 reported cases. So for instance, we can say COVID-df.new cases. So this is a series, or the column which is a series, and we can simply use the expression greater than 1,000. And what this does is this creates a new series. Now this series has the same length as the original series or column, except that it now contains Boolean values, false and true. So the false here indicates that at that particular index, the value within COVID-df.new cases was not greater than 1,000, was less than 1,000, right? So false is where the criteria was satisfied, and true is where false is where the criteria failed, and true is where the criteria was satisfied. So now what we can do is we can take this series of Booleans, the high new cases series, and we can pass that as an index into COVID-df, right? So this is another way of just indexing COVID-df, and then you use the index, and then you pass in this Boolean series. Now, when you pass in this Boolean series, what happens is wherever there was a true, those rows are retained, and wherever it was false, those rows are skipped, right? So you get back a subset of rows. Now these, you can see that there are only about 72 rows here, and this is basically another data frame, which is again a view of the original data frame. So here you can see that there are 72 rows, and in all of these rows, you can see that the number of new cases is higher than 1,000. All right. So this is, if the question was on how many days was the number of new cases higher than 1,000, you now know that it is 72, and you can actually pull out a full list of dates as well by just accessing the date column of the data frame. Now we can also write this very succinctly on a single line by simply passing the Boolean expression, so COVID-df.new cases greater than 1,000, as an index into the data frame, right? So this might seem confusing if you see it directly, COVID-df, and then it looks like inside the index you are once again using COVID-df. It might feel a bit odd, but if you look at it this way, that this creates a series of Boolean expressions, and then that series is passed in as an index to filter out the rows which satisfy that expression. So that makes it a little more intuitive, right? And you can see here that you get back the same result, which is 72 rows and 4 columns. Now, although there are 72 rows here, we do not actually see 72 rows. What we see is 5 rows, and then we see these dots, and then we see then we see the 5 rows at the end. And Pandas does this because your data frames can have tens of thousands or even millions of rows. So it will really slow things down, especially on the browser if you print out the millions of rows. But in this case, sometimes we might want to look at all the rows of data. And when you do want to do that, there is some special syntax that you can use. So there is an option context method that you can use where you need to set the display of max rows to 100 and or whatever you want. So you can set the maximum number of rows to be displayed to, in this case, I'm setting it to 100. And then you have to use the display function from ipython.display, right? So these are just some details that the specifics are not important, but the idea here is that you can use this kind of a syntax to simply display all the rows of data, right? And once again, this is not something that you need to remember specifically. You can simply search it online, how to show all the rows, or sometimes even columns are truncated. So how to show all the columns of a data frame, and you will find some syntax like this. Okay. So here are all the 72 days where the number of cases was higher than 1,000. Now we can also formulate more complex queries. So complex queries that involve multiple columns. Also often you may want to combine data from multiple columns to actually identify or create a criteria. So we already have a positive rate, which is the number of cases that out of the tests conducted, what percentage of or what fraction of cases turned out to be positive. So it was about 5.2% or 0.052. And now we might want to determine the days where the ratio of cases reported to tests conducted was higher than the overall positive rate, right? So you could interpret these as days where a lot of people got infected, or a high percentage of people got infected among the tests that were conducted, right? So the way we can do that is, once again, we have COVID DF, and then we pass in an index. So remember, whenever you're filtering out or querying something from a data frame, you have to use the indexing notation. And inside it, we have this expression. So we say COVID DF dot new cases. So that's a column or a series divided by COVID DF dot new tests. That is another series. So here we are dividing a series by a series. And as you might expect, that performs an element-wise division. So we get back a new series which contains the element-wise corresponding divisions. And so that is the kind of the daily positivity rate. And then when you check whether it is greater than the positive rate overall, that will give us the list of rows. The list of rows, which is about 12 rows or about 12 days, when the positive ratio, so that is the ratio of new cases by new tests, was higher than the overall average. All right. And as we saw here, you can even check this specific operation. So dividing two series or two columns by one another. So that simply gives you another series which contains the element-wise divisions. Okay. And further, what we can do is, whenever we do an operation like this, which returns a series which has the same length as the number of rows in the data frame, we can actually set that back as a new column into the data frame, right? And this is once again where the dictionary of lists analogy will make sense, because if you think of COVID DF as a dictionary, then into that dictionary you are adding a new key called positive rate, and into that new key you will add the values of that specific column. So the column being new cases divided by new tests, which we are calling the positive rate. All right. So now if we check the COVID DF data frame, you can see here that we have a new column called positive rate. And whenever there are nans in any of these calculations, you will also see a nan reflected here, right? In column wise calculations. Okay. But here's a detail to keep in mind. And this is once again going back to the context about the data, that sometimes it takes a few days to get the results for a test. So as such, we can't really compare the number of new cases with the number of new tests conducted on the same day, right? You may conduct 1,000 tests today, but maybe 500 of these results might come out tomorrow, and then another 200 might come out a few days later, and so on. On the other hand, the number of cases that were reported today could have contributions from tests conducted over many of the past few days, right? So comparing cases and tests on a day-to-day basis is probably incorrect, and any inference based on that is likely to be incorrect, right? So this is a place where you should dig in more and see what is the average duration it takes to get the result for a test, and how did that change over time, and so on, right? So it's important to watch out for subtle relationships like this in the data, which are not conveyed clearly by just the CSV file, right? So these require some external context. So you should always read through the documentation provided with the data set about how the data was collected, what are the processes involved in collecting the data. And if you have any questions on your own, then you might want to ask these questions from the source of the data set, right? Whether it is your company or some online source, you might want to ask for more information. Okay. So for now, what we can do is we can simply remove the positive rate column. So to remove the positive rate column, we call the drop method. So we say COVID DF.drop. And when we call COVID DF drop, we can remove one or more columns, and we can either get a new data frame out, so which will be a view of the previous data frame, or we can simply drop it from the existing variable. So COVID DF, right? So I'm just going to drop it from the existing variable so that we do not have to worry about a new variable now. So if we check COVID DF now, you can see that the positive rate is now gone. Okay. So now we've looked at querying data. We've even looked at adding new columns. But another thing that we might want to do is just sort these rows by a specific column. So for instance, you might want to identify what were the 10 days with the highest number of cases, right? And the way to do that is to first use the sort values method. So you can simply use say COVID df.sort values, and into sort values you can pass in the column by which to sort. So you can either pass a single column or a list of columns, And to figure out how to use these functions, a simple way to is to use the help function. So you can call help on coviddf.sort values, or you can simply press shift plus tab while the cursor is inside that method or that function, right? So if you do shift tab once or twice, you will see the full signature. So you can see here that the first argument is by, and by can be a string or a list of strings. So either a single column or a list of columns. And similarly, you can also specify whether you want to sort by ascending or descending order. And again, ascending can either be a single Boolean, or if your list of columns is a list, you can also pass a list of trues and falses, a list of Booleans, so that you can sort by descending and ascending with multiple columns as you require it. All right. So that's a very powerful way to sort, similar to what you might do in Excel or SQL. And then another thing that we have done is we have actually chained this. So the result of sort values is another data frame. And then we have changed that. We have chained that with the head method, and we are looking at just the top 10 elements from that sorted data frame, right? So that gives us the 10 days. So it seems like the 22nd of March was the peak with 6,557 reported cases that day. And then and it was mostly the last couple of weeks of March, it seems like, where most of the highest number of cases were reported. Okay. Now let's compare this with the days where the highest number of deaths were recorded. So here now we have coviddf.sort values, and here we are sorting by new deaths. And once again, we're looking at the top 10, and it seems like the 28th of March was when there was the peak, and then the 29th. So if you compare these two, it seems like overall that the daily deaths hit a peak just about a week after the peak in the daily new cases, right? So that might lead you to, and then you can dig in a little more and read some literature, and that might lead you to understand that, okay, maybe for somebody who's contracted a virus and is going to become seriously ill from it, so they are going to probably suffer the most within the next week or so, and they will either recover or not. Okay, so let's also look at the days with the least number of cases. And here, this might be obvious to you that, okay, the least number of cases might be in the first few weeks of January, but even then it's a good thing to look at. So I'm just going to sort these values. So coviddf.sort values, and by new cases, this time in ascending order, and pick the 10 lowest numbers. So as we might expect, we see a lot of days from the last day of December, and then we see a bunch of days in January. But here's one. So on the 20th of June, there seems to be the value minus 148, right? And now this is unexpected. You might not expect to see a negative number of cases in a day, but that is the nature of real world data. This is what happens, and it invariably happens with any real world data, and it really cannot get more real world than this, which this is data being updated based on real facts and real numbers being reported by hundreds of countries and hundreds of agencies and hospitals on a daily basis. So there are likely to be errors, there are likely to be discrepancies, and this could simply be a data entry error, or it's possible that the government may have issued a correction to account for miscounting in the past. So you may have to see the documentation around the data. And this particular data set that we have is pulled from Our World in Data. So you can go to Our World in Data, the website, and try to find out more why this might be the case. And I encourage you to dig through news articles online and figure out why this number was negative. Okay. But another thing that you might do if you do not have any external information is to just look at some of the days before and after that date where we have this negative column, right? This negative value. So if you look at the days, so this negative value was at index 172. So we can look at the few days before it and a few days after it. So it seems like the values for new cases were in the range of 210, 328, 331, and similar range after that, but only this value seems to have some discrepancy. Now, based on this, I am guessing, although I cannot know for sure, but I'm guessing that this might be a data entry error. And if it was, and if we are able to verify that, we can use one of these approaches to deal with this missing or faulty value. So one way is to just replace it with 0. Just say that we are assuming there were no tests, there were no new cases reported that day. But that is a little unlikely for this specific data set. It may not, it may be It may be likely for a different data set, but not for this. Another thing is to replace it with the average of the entire column. So we can say that, okay, we just take the entire average number of new cases and then simply put that in here. Again, you can do that in certain cases, but in this case, once again, it may not make a lot of sense because the variation is so high, the standard deviation is so high that the average here is probably not going to be anywhere close to the actual number. The average we know is about 1,000, but the actual numbers on the days before and after are actually more in the range of 300 or so, right? Another thing that we can do is to discard this row entirely. This is something that so in a lot of cases you can do this. You see some faulty data and it is okay to discard. It is not going to affect the overall results significantly. So you can just discard that data as well, that row of data. And one more thing, which is probably makes the most sense in this case, is to simply replace this value with the average of the numbers around it, right? So we can simply take the average of these two numbers or these two and these four numbers. So which approach you pick really requires some context about the data and the problem. In this case, we are dealing with data ordered by date, or what is called time series data. And that is why taking an average of the values around it actually makes a lot more sense. So now to do that, we need to modify that value within the data frame, and we can modify it using the same at method that we use for access, right? So we say coviddf.at, and so 172 is the row number or the row index, and then new cases is the column. And here we simply say that we want to take the average of the two values of the value above and below it in the data frame. All right. And with that, we have fixed, or at least temporarily fixed, the discrepancy in the data frame. All right. So these are just some ways in which we can filter out data and sort rows out of the data frame. So we looked at finding the sum of values in a column or a series. We looked at querying a subset of rows satisfying a given criteria. We looked at adding new columns by combining data from existing columns. And then we also looked at removing one or more columns from the data frame using drop. And then we looked at sorting the rows of a data using the column values. And finally, we looked at replacing a value within a data frame, right? And once again, this is not something that you need to remember by heart. On the other hand, you need not, and you can simply search for this online and you will be able to find the right resource. Okay, so now I've committed my notebook once again. So moving forward, as I just mentioned, this data is ordered by date. So this is what is called time series data. So while we have looked at the overall number for cases and tests and positive rates, it might also be useful to study these numbers on a month by month basis, because there is so much variation on the daily cases. So you might want to just drill down and look at a specific month or a specific week. Now to do that, the date column might come in handy here. And in fact, because so much data tends to have a date or a time associated with it, Pandas provides many utilities for working with dates. All right. So if you just check the date column here, so it seems like this is a series as we might expect, but this has the D type or data type of object. And that means that Pandas currently does not know that this column is a date. So what we might want to first do is convert this date column into a new column which has the data type of date time, and this can be done using pd.toDateTime. Okay, so we just say pd.toDateTime and then we give it a series, and it takes the series and then it converts those data types into the date time format. So it's an internal format within Pandas, and then what we can do is we can take that and we can assign it to a new column. But instead of assigning it to a new column, we can simply assign it back to the same column, because once you have the date in the date time format, then we don't really need the string date, right? We can always get it out from the date time format if we need it. So now if we check coviddf.date or coviddf indexed the date column, so you can see here that the data looks similar, but this time the data type is date time 64, right? So this tracks time up to a particular nanosecond, but since there was no time portion in the date, so you don't really see a time portion, right? But it tracks time up to nanoseconds. Okay, so what we can do is we can extract different parts of the data into separate columns using the datetime index class. So this is a really helpful class in Pandas. So all you need to do is take the series or the column and pass it into pd.datetime index. So that creates an object of type date time index. Now, if you want to extract a specific information, a piece of information out of it, you can do that. So if you want to get back the year, so we just do dot year, and then we can set, and that will return a series, and we can set that into the year column. Similarly, we can set a month column, and we can set a day and a weekday column as well. All right. So now we've just added 4 columns simply by converting the date column into a date time data type and then passing it into the date time index. Okay. And let's look at the data frame now. So we have the date as before. We have the metrics that we had earlier, but now you can see year, month, day, and even the weekday. So the months go from 1 to 12, January to December. The day goes from 1 to 31 or whatever is the number of days in the month. And the weekday represents Monday to Sunday. So Monday is 0 and Sunday is 6, and then you can guess the values in between. All right. So now that we have the month related information, so let us track the overall metrics for the month of May. And for this, we are actually going to do it in a few steps. So let us just see all the intermediate steps here. So first of all, we may want to query the rows for May. So here what we are saying is COVID DF May is COVID DF, and then we are indexing into it and passing a Boolean expression where the month column is equal to 5. And let's check the value of it. So there you go. You see about, looks like there are, so there are 31 values, or there are 31 values here, and you can count it as well. So there are 31 values and this contains the data only for May. Now the next step now is to get the sum for each column, right? So we want a sum for new cases, we want the sum for new deaths, and we want the sum for new tests. But instead of doing it column by column, we can also do it all at once on the entire data frame. But to do it all at once, we may want to first exclude the columns which we do not want to sum over, because for some of these columns the sum may not make sense. So we can simply extract just these 3 columns. So let's do that. So we create another data frame called COVID DF May metrics, where we pass COVID DF May, and from it we simply extract the columns new cases, new deaths, and new tests, right? So here we are using the indexing notation, and instead of giving it a single column, we are giving it a list of columns. And now you can check the value of COVID DF May metrics. And you can see here that it has 31 values, but only for the new cases, deaths, and tests column. Okay. And now finally, now we can get these totals. So instead of calling sum on each series individually, we can simply call it on the entire data frame. And when we do that, now we get back the totals. So now that the entire data frame collapses into a single series. So you can see that this is a series. And now we have the total number of new cases, which is 29,000 during the month of May. The total number of deaths was such, and the total number of tests was about 1,078,000. Okay. And this is how you should initially do it when you're learning pandas. This is how you should initially just go step by step, keep creating intermediate data frames. As I said, all the data is shared between the data frames, so you need not worry about it being very slow or taking up a lot of memory. So just keep creating as many intermediate data frames as you need. The most important thing is for you to have clarity about what's going on in your calculations, and performance and optimization can be an afterthought. But what you can do is, once you become comfortable with this, is you can actually start doing it in a single statement. So now here we are saying that, okay, we are getting the data out for May. Out of it, we are selecting a few columns, and then we are calling dot sum on those columns together, right? And that gives us the exact same result. Okay. So that's some data about May. Now you can try finding the data about January, February, March, and see how they compare. Now here's another example. Let us check if the number of cases reported on Sundays is higher than the average number of cases reported every day. Okay. So this time what we might want to do is, instead of aggregating, so we do not want the total number of cases on Sundays. We simply want the average number of cases. And we also want the average number of cases. We also want the average number of cases in general per day. Right. So the overall average, what we can do is we can say COVID df.new cases and call dot mean on it. So it seems like the overall average is 1095.78 cases per day. And the average for Sundays. So the average for Sundays, it looks like is COVID DF. So first we extract out the data for Sundays. So we say COVID DF dot weekday equals 6, and we pass that as an index. So the Boolean expression returns a series of Booleans, which we pass as an index to COVID DF. And from that index, we get back the new. So now we have only the data for Sundays, and from it we get back the new cases column by using the dot notation. And then we can, now that we have the list of new cases on Sundays, we can call mean, and that gives us the mean 1247. All right. So now it does seem like more cases were reported on Sundays compared to other days, right? And you can get this information for each day of the week. And now at this point is where you might want to go do some investigation, do some research, and figure out why it was the case. Okay, so data analysis cannot be done within a silo. Any data that you analyze and any inferences that you come up with, you have to then go and investigate why it is so. All right. So those are just some basic questions that we've asked about our data. But try asking some more date-related questions about the data, and and share your results on the forum. If you found some interesting insights, share the results, discuss what might be the reasons behind those insights. Who knows, you might discover something new. Okay. But what we really wanted to do as we started talking about dates was that we wanted to summarize the day-wise data, and we wanted to summarize it on a month-wise level, right? So instead of having the new cases, new tests, and new deaths on a daily basis, we might want to see them on a weekly basis or on a monthly basis. And this is again a very common use case. Often the data, and this is called the granularity of data. So often you may have data that is collected per millisecond, or you may have data that is collected per second or per minute or per hour, per day, and you might want to change the granularity. Now obviously you cannot go back from hours to minutes, but you can combine the data from minutes to hours, right? So in this case, what we want to do is we want to combine the data for multiple days within a month into a single row of data. All right. And the way to do that is using the group by function. So in the group by function, what we need to do, it's a function of the data frame. So we say COVID df dot group by, and let's just do it step by step here. So we say COVID df dot group by, and then we want to group by month. So what this does is it does not show you any output, because this is an intermediate data structure. It does not really do anything. It simply collects some information about how you want to do some grouping. But conceptually, what you can think it does is that if you look at COVID DF, so here you can see that there are a lot of values for month, and in fact month has about 10 values. So there is 12 for December 2019, and then there is 1 to 9 for 2020. Now fortunately all the data is from a single year, and so we do not need to consider just month and year, but in some cases we might want to group by month and year. But in this case, if we just group by month, what happens is Pandas creates one group for each unique value of month. So for the month of January, all the rows are collected together into one group. Similarly, for the month of February, all the rows are collected together into one group, and for the month of March, April, May, June, and so on, right? So each month, the rows for that month are collected into a single group. Now what do you do with that group? Now on that group, you can do you can then say how to aggregate the information in that group, right? So what we might want to do then is that for all the data, all the rows in January, we may want to add up new cases, new deaths, and new tests to get back the total number of cases, the total deaths, and total tests in that particular month, right? But before we do that, now to do that aggregation, we may have to first ignore all the other columns, right? So just like a data frame, a group by also allows you to specify which columns to keep. So once you've done a group by, once we've done a group by, let's put this into a variable called group. So let's say monthly groups. Okay. So now from the monthly groups, before we summarize the data, we may want to simply say monthly groups, and out of these simply select the columns that we want to look at, right? So monthly groups. Now you can see here that we still get back at group by object. So we are still in an intermediate state. No aggregation has been performed yet. But what we can do is we can select these columns and then we can call dot sum. And now what you see is a new data frame, a completely new data frame. So the original data frame still exists, but this new data frame, the index, it does not have the same number of rows as the original data frame. In fact, the number of rows here is equal to the number of groups in the grouping column, right? So month had 10 values in total. So you have 10 rows, 10 elements in this, 10 rows in this data frame. And then we had selected 3 columns, new cases, new deaths, and new tests. So now for each of these groups, so these are the 3 columns that show up in the result. And for each of these groups, we have then performed an aggregation using sum. So that's where you can see that the total number of cases reported in January was 3, and then it grew to 885, and then it grew to 100,000, and it remained at 100,000 in April, and then it started going down in the month of May. And then you can see here that it started going down, but it seems like the number of cases seems to have grown again in the month of August, right? So it seems like there might be a second wave going on here. So, and already you can see here that simply by grouping and aggregating the data onto a monthly basis, we can already make some more inferences than we were able to do previously using just the date level data. And that is really the whole purpose of data analysis. What we are doing is we are transforming data from one form into another, whether it is aggregating it, whether it is creating new columns, whether it is creating new groups, or whether it is sorting in a certain way. So we are simply moving the data around to gather more inferences about the data. All right. And the underlying data remains the same. Now we will take this idea further next week, where we also use this to plot graphs, because you can, while you can see the trend here, you cannot really see how drastic the change is. And that is where humans are able to perceive things much better visually, especially when they are comparative. So we will also look at a few ways to draw some graphs. All right, so that's grouping, and there's a lot of depth in grouping. So you should probably just check out the documentation or read a tutorial on grouping in Python, in pandas. But we will just leave it at this one simple example, or maybe let's do one more. So let's do this. Let us, instead of aggregating by sum, let us aggregate by the mean. And let me pose the question this way. So let's try and find out what was the average number of cases reported on every weekday. All right, or average number of cases or tests or deaths. So we group by weekday now, and then we select the columns new cases, deaths, and tests, and then we call dot mean. So instead of aggregating by sum, we can aggregate by mean. So there are a lot of ways to aggregate. You can aggregate simply by the count. So if you just want to see the counts, in this case, the counts will be equal for every weekday, because we have over time the number of weeks. Each week has 7 days. So the count is not very interesting, but sometimes that might be interesting. But then you can also aggregate by just keeping track of the maximum, and you can aggregate by keeping track of the minimum. So there are a lot of ways to aggregate, but we are aggregating by mean. And when we do that, we can see here that for each weekday, we can see how many new cases on average were found. So on average, 1100 cases on Mondays and 1200 cases on Sundays. And it seems like on Tuesday and Wednesdays when on average you had the lowest number of cases. All right. And then you might want to now dig in and investigate that. Why is this the case? Maybe it has something to do with the testing methodology. Maybe it has something to do with the reporting. And maybe you can see that, okay, how does it compare with the average number of tests? So it seems like the average number of tests was highest on probably around the 4th day. So which is Monday, Tuesday, Wednesday, Thursday, Friday. It seems like the average number of tests was the highest on Fridays, but the average number of reported cases were highest on Sundays. So it might suggest that it seems like that maybe it took about 2 days for the test results to come out. But this is where you have to then go back and investigate a little more. Okay. So now, apart from grouping, another form of aggregation is to calculate the running or the cumulative sum, right? So we have in our data frame, we have data for on a daily basis, in the original data frame. So once we look back here, so we have new cases, new tests, new deaths. But what we might also want to know is that up to a particular date, what was the total number of cases? And we might want that information on a daily basis, because that is again another interesting trend to study, right? So the way to do that is using the cumulative method. So there is a cum sum, CUM cum sum method, but there is also a cumulative maximum, there is a cumulative mean, and there are a lot of other ways to accumulate the data on a row by row level. So let's just call cum sum on new cases and set that into a new column, total cases. And similarly, we do that for the deaths and the tests as well. And now what we've done is, by the way, for tests, we have also included the initial test count. So this is again to account for, there were a lot of days where daily tests were not reported. So we have accounted for that as well. And now when we check the data frame, you can see here, apart from new cases, new deaths and new tests, we have total cases, total deaths and total tests as well. All right. So that's pretty good, that now we have this information to look at too. Notice that the NaN values still remain here. So you can still see that the total tests was NaN. So the cumulative values tend to remain NaN till you have a single NaN value. And actually, whenever you see a NaN value, the cumulative result turns out to be NaN. Okay. Next up, now we have the cumulative information, and we've gathered a lot of information about our data, about our data set from the data that was given. But more often than not, you might need to merge data from multiple sources. So you might want to calculate, let's say we want to calculate a metric like tests per million or cases per million. And so for this, we require some more information about the country, specifically its population in this case. Okay, so let's download another file, locations.csv, which contains the health related information for different countries around the world, including Italy. Okay, so we have URL retrieve here, and this is where we're passing in the full URL, and we're passing in a CSV file name where we want to download this data. Once again, we read this into a data frame and we can check it out here. So this contains the location. It contains, which is basically country, but there are also one entry each for world, and then international, that was to track for any country, anything that was happening not in any specific country's borders. But yeah, we have location, continent, population, life expectancy, hospital beds per thousand, and GDP per capita. So we will only be using the population data right now, but in the assignment that you will do after this lecture, that you will end up using all of these different, all of this different information about each of the countries. So let's just check, let's verify that Italy is here. So the way to verify is, once again, we just have a Boolean here that we want to check that the location is Italy, and pass that as an index into the locations df. So it looks like Italy was there. It was at the 97th index, and it is in Europe, and it has a certain population. So it seems like it has a population of 60 million people. And then there's a certain life expectancy and beds per thousand and GDP per capita. All right. So now one thing you might just do is take this population and then just use it directly for our calculations. But a more interesting thing that we can do is to insert all of these columns, all of these values into every row of our data frame, right? So and why might we want to do that? So we have COVID DF. Let's take a look at it. So this is our COVID DF data frame, right? And right now we only have the information for Italy, but it's possible that we may have information for multiple countries in a single data frame. All right. So we may have, let's say, if I introduce a new column called location, and right now, because we only have data for Italy, I'm just going to set it to Italy. So now we know that for Italy, so in the location Italy, on this particular date, these were the metrics. And similarly, in the location Italy, on this particular date, these were the metrics. And then, you know, we can do the same analysis for, let's say, Spain and Portugal and Germany, and then we can put all those data frames together. So you can imagine having a data frame where you not only have data for Italy, but also have data for Spain and Portugal and all of these other countries, right? So location may take different values. Now, when we want to calculate the per million metrics, then a good idea would be to introduce a few new columns into the data, right? So for each row, if we could introduce columns like continent, population, life expectancy, then we can calculate a few more metrics. All right. And the way to do that, so the way to join these two data frames is to use the merge operation within Python. But to merge the data frame, you need to have at least one common column. And in this case, the common column is Italy, right? So the location Italy is common column is location. So the location column can actually be matched up. So what we can do is for each row here, we can look up the location. For that location, we can look up the data from the locations data frame and insert that as new columns within that row, right? And the way to do exactly that is to use the merge method. So here we take the source data frame, which is the COVID data frame. And in the COVID data frame, we are saying that we want to get information out from the locations data frame. And how do we want to get the information out? We want to get the information out using the location column. So for each row of the COVID data frame, we check the location. And then for that location, we get the data from the locations data frame. And then we insert that data into that row as new columns. Okay, so let's see what that looks like. So here we have the same data as before, and we are calling this merge df because it returns a new data frame. So COVID df still contains the original data, locations df remains undisturbed, and merge df will now contain the merged information. So now in this merged df, you can see here that we have the same information that we had earlier, but after location, you can see a bunch of new columns were inserted, and these columns are fetched from the locations data frame. Okay, and these are the data for the corresponding locations. Now, since we only have Italy in our COVID df data frame, you can see that all of these rows pretty much have the same data. But if we had multiple locations, you would see different data for each corresponding location. Okay. So now we can calculate metrics like cases per million, deaths per million, and tests per million. So we simply take the total number of cases and then we divide it by the population. But because the population is the overall population, we need to divide the population by a million, or we can simply bring it up here. So this is just to account for the per million calculation. And now if we check our merged data frame, now we also have this information of cases, deaths, and tests per million people. And that's an important metric probably to look at when we are comparing countries, because between countries, what we really might want to know is not the overall number of cases, not maybe even the number of tests conducted, but more the per million or per capita number of cases. And that's where this is useful. Okay. So that's merging. So now we have merged our data, and with this, we've pretty much done everything that we can do with a pandas data frame. There's still a lot more for sure. There are many different kinds of functions to explore. There are many different things that you can do, but this is some of the common things that you do. And we are using a real world data set. So this is like a real world data analysis that we are doing. And what we might want to do after doing some analysis, after creating some new columns, it would be a good idea to write the results back to a file, because right now we are running a Jupyter notebook, which is running on Binder. And whenever this Jupyter notebook shuts down, the data will be lost, right? All the analysis that we have done so far. So before writing this data to a file, the first thing we might want to do is just create a smaller data frame, because now while you're working through your data, you may create tons of columns. You may create dozens of columns, and you may sometimes you may create columns that you don't even really need. For instance, we've not really used the weekday data or the day data. And while we are exporting this back to a file, since we already have a date now including year, month, day, and weekday is somewhat redundant. So what we can do is we can once again create a results data frame where we can get rid of all the intermediate columns that we had created, which we don't really need. We also pulled in a lot of columns from the locations data frame. Once again, we may not really need them. So we are simply going to keep the date, the new cases, the total cases, the similar metrics for deaths and tests, and then the per million metrics. Okay. So we take this and check it out. So result df here. And now this is the information that we want to save to a file. Now to save this data to a file, we can use the toCSV function or the toCSV method of a data frame. So we simply say result df.toCSV, and then we pass in results.csv here, which is the file where we want to write to. Now, if this file already exists, it will get overwritten. And then we also set index equal to none. So this is a small detail that you need to know about pandas. This is a common error that I tend to make all the time. So what pandas does is it also treats the index as a column while writing to file. Because sometimes that an index need not just be just numeric indices. For instance, we saw that month was an index earlier or weekday was an index earlier. So sometimes you may want to retain that information, but in many cases you don't. So since we do not want to retain the index information, we do not want an additional columns going from 0 to 247, we can just say index equal to none or index equal to false, and that will tell pandas not to include the index in the output. Okay. So now once we do that, we have now created the file. So we can open up that file. So we can go file, open, and open up the results.csv file. And now with this results.csv file, you can see here that these are all the columns that were exported, and this was the data for all these columns. And wherever the data was nan, so now just as empty values got read as nans, so same way nan values get written as empty values within the CSV file. But you can see here, probably sometime in March, you can see that all the numbers most of the numbers at least have non-zero values over time. So that's how you save data back. And then you can, just as you can read many different file formats, you can also write back to different file formats. Like you can create a SQL file, you can create an Excel file, you can create a JSON file, and so on. Okay. Now, one other thing that you might want to do is, one thing you can do is you can simply download this file. So you can select results.csv and click download to download this to your computer. And by the way, if you can also use the upload button to upload files from your computer. So if you have a CSV file sitting on your computer and you want to upload it to Binder, then you can just click the upload button and select the file instead of using the URL retrieve method to download it from an online URL. In any case, so that is one way you can keep the file around. But it would be nice to, since we are already putting our Jupyter notebook on jovian.ml, it would be nice to also attach the file as an output of the Jupyter notebook, right? And in fact, as we do multiple analysis, each time we may get back different results, right? If we come back tomorrow, get the new data out, then we may get new results. And for that, what you can do is when you do jovian.commit, you can actually specify an outputs argument, and in the outputs argument, you can specify a list of files or folders. And what Jovian will do is it will, along with the Jupyter notebook, it will also capture and upload the results.csv file. So let's take a look at that. So here we have created version 14. So every time we run jovian.commit, a new version got created, and you can see the same Jupyter notebook here in a read-only mode. And then you can click run and run it on Binder, and the whole, just exactly as you might expect. But if you check the files tab, you will find on the files tab that there is a section called artifacts where you can see the results.csv file. So this is the results.csv file, and you can view it here. You can view the raw file. You can even delete it if you want to get rid of it, or download it if you want to simply pass it on to somebody, right? And now each version will get a different results.txt file. So this is a good way to keep your outputs organized. All right. And that's pretty much it about writing data out from pandas into a CSV file. Now I want to take a few questions at this point. So let's see what questions we have. Okay. So the first question that we have is, why do we use pandas when data analysis and presentation can be done in SQL or Excel? Okay, so that's a good question. And there are two parts here. The first question is about SQL, let's say about SQL and Excel. Let's answer that first. So yes, you can do a lot of this analysis in SQL and Excel, but SQL, for instance, is one limitation that you might face is that SQL only works with database tables. So if you want to combine data from multiple sources, one of which is a SQL table and one of which is an Excel file and one of which is a CSV file and one is a JSON, and that is just how real world data is, that you may have some COVID data in your SQL database, but then you may have to download a locations.csv file from somewhere, and then to combine them, either you have to create a new table. Now pandas lets you avoid all that. You can pull data from any format into a pandas data frame, which is held in memory, and then combine them and then perform all these operations. So that's one benefit. And the other thing is that SQL is a very limited language. So Python being a general purpose language, you can write functions, you can reuse the code, you can use the pandas library, and then there is a whole ecosystem of thousands of libraries that you can use, which are built on top of NumPy and pandas, like things like SciPy and so on. So that's something that you can draw into, and that makes whatever you want to do, you can possibly do that in just a few lines of code. Whereas with SQL, SQL interviews are the hardest because you have to write everything from scratch, and you have to write these huge expressions which all have to be within a single line. So it's not very convenient and it's not very reusable, right? And you can use variables within pandas, within Python. So that's a benefit. Then comparing it to Excel, well, if you are able to do all the analysis that you need to do within Excel, that's great. And that's a good place to start. You need not really use pandas if you can do all your analysis in Excel. But when you want to scale things, like we've done analysis for Italy, but now we want to do this similar analysis for 100 or 200 other countries. Now at that point, it might get a little difficult to do that in Excel, because you cannot really capture all of the analysis that we did into some basic Excel formula, or even like an Excel macro. So that is where, again, pandas, this might be useful. You can take all the analysis we have done, put that into a function, and use that function to analyze hundreds of files. So that's about SQL and Excel. And then the second question was about presentation. Now, in terms of presentation, what I would say is that the Jupyter Notebook is probably a better way to present, because you can add all of this explanation. You can draw graphs within a Jupyter Notebook, and it has this sequential order, it's also very well suited for like a narrative or a storytelling kind of a flow, where you can present all of your findings in a structured format. And there are ways where you can hide the code and so on. So I would say that Jupyter is actually a good way to present. And what you can do is you can simply take the Jovian URL and you can share that. And that is a good way to just present, like create a report and share it. Like if you're doing a project and you want to create a report, you can simply upload the notebook to Jovian, and that's the report right there. What you can also do is, now you can also see previous versions. So that's one other benefit, that if you're, let's say, doing this analysis on a daily basis, you can always go back and check previous versions. Versioning is not something that you can do easily with Excel or SQL. So these are just some of the benefits of, I would say, benefits of programming in general, but using pandas and Python and Jupyter in particular. All right, let's take another question here. Okay, so there was another question. Is it better to write individual statements, or is it better to combine multiple statements into a single statement to improve performance? Well, in general, what I would suggest is it is better to do the thing that you find the most clear, because the performance hit that you're really taking, unless you're working with millions of rows of data, is maybe you go from 1 second to 5 seconds if you split something into multiple lines or do something a little bit inefficient. But I would suggest that that's probably totally worth it, rather than trying to create one long expression or one long statement that you don't really understand. So initially, try to break things down, try to write small statements, and over time, as you get the hang of it, try to write single statements, because ultimately it is true that a single expression is going to be faster or going to be more efficient. Okay. So now let's talk about plotting, and this is something that is leading into the next lecture. So typically we use a library like matplotlib or seaborn to plot graphs within a Jupyter Notebook. But pandas, data frames, and series also provide a handy plot method for a very quick and easy plotting, right? So we're not going to learn a lot about the syntax for plotting, but we will see how to draw a few graphs. So the simplest way is to just call the plot function on a series, and you can say, and that plots a line graph. So here we take the result data frame, and then we check the new cases, and then we just call plot. And you can see that plots a line graph. So here you go. So now we've been looking at this data for about an hour and a half, but only by looking at this, and so far I don't think we've had that insight of how exactly the trend was on a day-to-day basis. But just by looking at this single picture, we know now, probably now know more in a different sense that we did all this while. So you can see that the trend is the number of cases increases to a certain point, hits a peak, and then it goes down. And then it seems to be going up once again. So there seems to be a second wave happening right now. So that's just, so this is just like a line graph visualizing the number of daily cases. Now it would be nice to see, it's hard to tell where the peak occurred exactly because it is simply using the indices that are already there in the series, right? And those indices go from 0 to 248. So we might have to do some mental maths to figure out where the peak occurred. But we can actually put the dates on the x-axis, and the way to do that is take the date column and convert it to the index for the entire data frame. So what we can do is we can take the result df and then just set the index to the date column, and we just do it in place so that we don't want to create a new data frame. So now we check result df. You can see that the index is now gone, and now the date is the index, and this is no longer a numeric index. Now this is a date time or a string index essentially, right? And now we can in fact even access the data for a specific date. So now into loc we pass not the index like a number 1 to 248, but we actually pass the date, and then we can get the data out for that specific date. Okay. And every series that we extract out will also have the date. So if we check results, result df.new cases, now each of these series or each of these columns will have the date as the index, right? And that is just one of the benefits of using series, that it can let you index using a specific index and not just numbers. So now that we have this, the next time we run plot, so now if we plot new cases, and what you can do is you can also combine plots. So you can also say .new deaths, and we are going to plot that as well, just to compare, okay, what was the ratio of cases to deaths and what was the trend looking like. So we can plot them. And now you can see that we have a graph. It has the data for new cases, which is the blue line, and the data for new deaths reported, which is the orange line. And then we have the x-axis also shows the months. So as we saw earlier, it seems like towards the mid or towards the last couple of weeks of March was when the maximum number of cases was reached. And just about a week from there, about 7 days out, was when the peak number of deaths was reached, right? We can also compare the total cases with the total number of deaths. And you can see here that this number grows up to a certain point. And it seems like it is increasing again, but the number of deaths seems to have mostly flattened out, right? So this is what, when we talk about flattening the curve, that was a popular term initially. Well, this is the curve that we talk about, that we are flattening. Well, actually, this is the curve that we're talking about flattening, because we want to reduce the number of cases on a daily basis. So what happens when you do social distancing, when you wash your hands regularly, when you wear a mask in public, is that the daily cases probably will not hit such a high peak. It will actually go slightly lower, and it will take a longer time, but overall it is not going to reach that peak. And you can see here, while the second wave is coming, it doesn't seem like it is growing at the same pace or at the same speed that it was growing earlier. So it seems like we've flattened the curve to a reasonable extent. At least Italy has. So let's see how the death rate and the positive testing rates vary over time. So we can also plot them. So here is how the death rate changes over time. So the death rate is simply the total number of deaths divided by the total number of reported cases. So you can see that initially it is low because the number of cases is very low, and you know, it's mostly people coming from different parts of the world. So initially we were not really tracking, they were not really able to account for all the cases because testing was limited, and probably even deaths were not being diagnosed as COVID deaths. But over time that number has increased as the contact tracing improved. So the people who were being tested were specifically being tested, people with symptoms, people who had come into contact with other COVID patients, and that's why this number may have gone up. And now it seems like maybe the pressure on the hospitals is now not as high. So it seems like the death rate seems to be going down once again, right? So different parts of this curve may have happened for different reasons, and you need to be you need to be following the recent developments. You need to be reading the literature, reading the research to come to an informed understanding of why this seems to be happening, right? And this is the common pattern. You see a certain you see a certain trend or you see a certain pattern and then you wonder why it is. Maybe you take a few guesses, but your guesses are just guesses. So what you then need to do is go back and back up those guesses with evidence and see which of your guesses are correct. Okay. Then we have the positive rates. So the positive rates also, well, the total number of tests was only tracked from April. So the positive rate data is available only from April. So it seems like that over time testing was increased to cover a wider number of people. So initially, while only people who were very sick or had very strong symptoms, or it was well known that they had either come from a foreign country or they had come into contact with another COVID patient. So only those people were being tested, and that is why the positive rate was quite high, about 18%. But over time, as more tests are being conducted, even for healthy people, just to identify, contact, test and trace people, you can see that the positive rate seems to have gone down, right? And its overall positive rate is currently at around 5%, which means that there is a fairly good level of testing. Finally, let's also plot some month-wise graphs. So remember, we had this month-wise data. Okay, let me just grab the monthly information here. Yeah, so here we have the month-wise data. So this is the month-wise data that we have. So for each month, we have the total number of cases, deaths, and tests. And then we can come back here and we take the COVID month TF, the cases, tests, and deaths, and then we can simply plot that. So here is the number of cases per month. So you can see here that in January, there were no cases pretty much. Actually, it was about 3 cases. And this time we have chosen a bar plot. So when we have a smaller number of elements on the smaller number of values on the x-axis, then it helps to have a bar plot. It can give you a slightly better idea for comparison. So it seems like the months of March and April were the worst, where there were the most cases, and then the number of cases went down quite significantly starting in May. And then May, then June, and it seems like it is on the rise again in August. And then in September, we've just had a few days. So we need to see how the trend turns out in September. But definitely now we are a lot better prepared. Every country is now a lot better prepared. So this number should probably not go as high as 100,000. Then here we are looking at the number of tests being conducted. So again, we do not have daily test data for Jan, Feb and March, and even half of April. So you can see that testing really picked up in May, and Italy has continued to conduct a large number of tests. But even though the large number of tests are being conducted, the number of positive cases is low, which means that probably the country is doing a good job of containing the positive cases. The country is doing a good job of isolating people. Maybe people are also following things like wearing masks in public and avoiding and doing social distancing. And as you compare this information, ratio of tests conducted and positive cases, and maybe even positive cases and death rates, you get to know about the per country situation, and every country is unique. So you really need to dig into the data to really understand how things are unfolding in each country. Okay. And with that, we complete our discussion of data analysis with pandas, especially for tabular data. So we can do one final commit. And now we are ready to move on to the assignment. But apart from that, I've also listed a few other resources you can check out. So here are some exercises on pandas. You can check out the official user guide, or if you want to, you can check out the book by Wes McKinney, the creator of pandas. It's called Python for Data Analysis. It is a huge book, pretty comprehensive, and a lot of the material in this course is also inspired. In fact, a lot of material in general related to data analysis is inspired from that book. So do check it out as well. So now let's come to the assignment. And before I come to the assignment, I just want to give a quick update on assignment 1. So for assignment 1, the evaluation is currently in progress. So about a large number of you would now, if you open up assignment 1, you might see that you have a completed grade, and you might see a grade along with each submission. and we are just tallying up all the results and going through any discrepancies. So by the early next week, you will actually receive emails with your final grade for assignment 1. And if you get a fail grade, you will still have a chance to make another submission. So don't worry, if you get a fail grade, we will tell you the reason for it and you will be able to fix it. Okay. And similarly with assignment 2 will be graded next week. The deadline is the 12th of September, and assignment 1 is still open for a few more hours. So you can still submit if you have not submitted. But let us come to assignment 3, pandas practice. So let's open up assignment 3. And the objective of this assignment is essentially to gain some hands-on experience with the pandas library. So the things that we learned today, you will get to apply them. So things like creating data frames, querying and indexing operations, grouping, merging and aggregation, and dealing with missing values. And to get started, you can simply open up the starter notebook. So here is the starter notebook, and it contains the information that you need to work on the assignment. And the first thing that you might want to do is just click run and run it on Binder. And you can do this assignment completely using Binder. The basic idea here is that you will see in a lot of places, you will see question marks. So you will see 3 question marks in certain places, and your job is to complete the assignment. To complete the assignment, you have to replace these 3 question marks with appropriate values, expressions or statements to ensure that the notebook runs end to end properly. Okay. And some things to keep in mind is that to make sure that you run all the code cells, because if you do not run, if you miss a certain code cell, then you may get errors like name error or undefined variables. You do not want to change the variable names that are already there. You can create new variables and you can add new cells, add new code, but do not delete existing cells, do not change variable names, and do not disturb any other existing code, because that may cause problems during the evaluation. And in some cases, you may need to add more code cells or new statements. So feel free to do that. It's not that you just have to replace the question marks. You can write additional code as and when you need it. And you can do this assignment on Binder. But since it is a temporary online service, then you do need to save your work by running jovian.commit at regular intervals. And ideally, we recommend doing it after solving every single question. Then finally, there are some optional questions here. So these will not be considered for evaluation, but we highly recommend doing them. They are for your learning. But if you are running close to the deadline, then you can skip the optional questions and work on them later. Okay. So let's look at the notebook. So I have just clicked the run button and selected run on Binder. And now on run on Binder, here I can open up the notebook, pandas practice assignment. And the same thing that I like to do always is to just clear the outputs and toggle the header and toggle the toolbar. Okay, so now in this assignment, the first thing that we do, the very first thing that we do is we simply import Jovian and commit. And the reason for doing that is so that you can save a snapshot of this assignment to your profile. So let's just copy our API key from our profile and paste it here. And so now you've taken the starter notebook and created a snapshot that is saved on your profile. So the next time you want to continue your work, you need to open up this URL, which is on your profile, and then click run from there. Okay. Now here you have to run this line to install pandas. So we are not automatically installing pandas so that the assignment runs a little bit faster for you. But each time you run the assignment, just on Binder, just make sure to install pandas. And then we install import pandas as PD. So this is all done for you. So in this assignment, we are going to analyze and operate on analyze and operate on data from a CSV file. So this is the same locations.csv file that you saw, but we've cut it down to just 210 countries. So this is the information, health related information for 210 countries. And we will do some analysis on that. So here you can see questions like how many countries does the data frame contain? So you can try and answer this question. Here's a hint. Well, you can also see the number here and put in the number directly, but here's another hint. So you have the countries DF. We have seen the shape method, and the shape contains the number of rows and columns. So it seems like there is one row per country, and you can verify that by looking at some sample data and just make sure that there is one row per country. So you can then, in that way, you can check how many countries there are. And then you can take this information and then simply put it here, either directly like by typing the number or by simply getting the first element out of this tuple. Okay, whichever way you do it is completely fine. And then you answer the question and then you print it out. And at the end of the question, just run jovian.commit again. And we do that for every question just so that you don't lose any work. Then you can retrieve a list of continents from the data frame. So there is a method here. Here's a hint, use the unique method of the series. So you can see that for each country you have a continent. Can you get the full list of continents out from the data frame using pandas methods? Try to do that. Then there's a question to find out the total population across all the countries listed in the data set. So each country has a population. So if you add up all the populations, you get the total population of the world approximately, because there might be some small minor countries which are not included here, and the population also keeps changing daily, but this would give you an idea of the approximate population of the world. Now here's an optional question that you need not do, but it's an interesting one to try out. What is the overall life expectancy across the world, right? And your first thought may be to just take an average of life expectancies across countries. We have a column for life expectancy, but you might not want to do that because each country has a different population. So it's not right to say that you give an equal weight to the life expectancy of, let's say, Andorra, which only has 77,000 people, and a country like Afghanistan, which has 38 million people. So you may want to take a weighted average using the population as weights. So try that out. This is an interesting question to try out. Then we have basic sorting and filtering. So here we are asking for creating a data frame containing 10 countries with the highest population. So here you can use sort values and then you can use head. Then we are also trying to add a column here. So add a column into the country's data frame to record the overall GDP per country. So the overall GDP is simply the product of the GDP per capita, which is given in the data frame, and the population of the country. Then here is a slightly more complex question. Create a data frame containing 10 countries with the lowest GDP per capita among the countries which have a population greater than 100 million. All right. So that's just it's a 2 or 3 step problem, and you can try to solve this as well. And create a data frame that counts the number of countries in each continent. So this is, again, now here you might want to do some kind of grouping and aggregation. So here we are counting. So here we might want to aggregate using count. There's another question to show the total population for each continent. So you might want to group by continent and simply select the population column and aggregate it using the sum. So that was the first part. And then the second part is to merge this data with some COVID-19 stats. So once again, there is this file called COVID-19 countries data. So here for each country, we have the total cases, total deaths, and total tests. And a lot of countries, the total tests are actually not reported. So that's where you see nans. And that's what the first question is. Count the number of countries where the total tests data is missing. So just use the isNA method to do this. That is a hint here for you. And all of these, even if this hint wasn't available, you can simply say count the number of missing values in a column pandas, and that will give you this same result, right? So this hint is essentially just saving you a search, but do try that out as well. Then you will merge the two data frames, the countries data frame and the COVID data frame, using the location column, and that you might want to use the merge method for it. Now, once you've merged it, you can calculate the tests per million, cases per million, and deaths per million. And then now you can look at what were the countries with the highest number of tests per million people, what are the countries with the highest number of positive cases per million people, and what is the what are the countries with the highest number of deaths per million people. All right. So that's something to try out. And then here's an optional question. Here is where you can try and check, okay, just to get an idea of maybe which country has managed things well. You might want to count how many countries feature in both the lists of the highest number of tests per million and the highest number of cases per million, right? So is it true that more testing necessarily leads to more cases, or are there cases where even with a small number of tests, you have a large number of cases, right? So do this kind of an analysis, and really ask these questions and ask these questions of your data. We've only mentioned a few optional questions here, but you can go on and asking more questions, and that will let you draw your own inferences on how different countries are dealing with the outbreak. And then you might also have to go back and you have to figure out how these test numbers are reported, because each country tests differently. There are different types of tests. There is a test which is a test for the virus, and then there is a test which is a test for the antibodies. And it seems like both of these numbers, the total gets reported. Some countries are reporting only the number of samples and not really the number of diagnoses, or some countries are reporting just the number of diagnoses. Some countries are reporting just the unique number of people tested, and so on. Right? So just keep that in mind, that there is a lot of nuance and a lot of subtlety in this aggregate information. So it's not always fair to just calculate these metrics and make assumptions or make inferences on top of it. Although that's a good starting point, but from that point you need to dig in and learn more. And the more original research that you do, the better your understanding of the situation improves. So please try and do as much as possible. In fact, and there's one more final question before that, and then I'll talk about the data set itself. So this question is to count the number of countries that feature in both 20 countries with lowest GDP per capita and 20 countries with the lowest number of hospital beds per million. But for this question, you should only consider countries with a population higher than 10 million. Okay. So this is a complex 3-4 part question. And then you can all you need to do is do it step by step. Get the list of countries with a population higher than 10 million, and then get the 20 countries with lowest GDP per capita, 20 countries with lowest number of hospital beds, and then count the number of countries which feature in both lists. And then you can see if GDP has, what kind of a relation GDP has with healthcare facilities in a country. Okay. And once you do that, once you solve each question, just keep committing. And then when you are ready to submit, just take the link. So the link that you get once you commit, this is from your Jovian profile. Just take that link. You can also get this link by clicking the share button and clicking the copy link button here. So take that link and come back to the assignment page and make a submission here. So you can just paste the link here. It needs to be a Jovian ML link on your profile. And when you do that, you can see here that it gets added. And you will see that the evaluation is currently pending. So we will evaluate once the deadline is closed. But a few things to keep in mind is to always use a Jovian ML link, because we are going to do automated evaluation. So do not submit Binder links, because Binder shuts down after some time. Do not submit Kaggle or Colab links, because we cannot extract that Jupyter notebook out for automated evaluation. Okay. So with that said, I wanted to just share a little bit about where this data came from. So this data came from Our World in Data. So I just searched for Our World in Data, COVID raw data. And you can see here, this is the source data for this analysis. And in fact, what we've done is we've taken this original data set, which is in CSV format, and we've extracted out just the information for Italy. So one good exercise for you is to download this CSV file. And from this CSV file, we've done analysis for Italy, but what you might want to do is pick your country, and for your country, just extract out the same information, which is a data frame or a CSV file containing the dates, the daily new cases, new deaths, new tests. Just keep these 4 columns and then repeat the analysis for your country. And how do you repeat the analysis? Well, so the way to repeat the analysis is you take this lecture notebook that we have. So let's go all the way to the top here. And alongside, you open up a new notebook as well. So here I'm just going to go File, New Notebook. Okay, and keep these side by side and download the data for your country, or first create the data for your country and then download the data for your country. And then for your country, just start typing out each of these lines one by one, right? So download the data using URL retrieve, or you can simply upload it into the Jupyter notebook, and then you can start typing out each of these one by one. So import pandas as PD. And then if I have the data for India, I might do COVID df equal to pd.read csv and India device .csv. Now once that is read, then I might want to look at the data frame and get some information about the data. So type out each line of code, and typing it out is a great way to just get some practice, because then you feel more confident typing it out. Then you feel more confident with each of these functions. You feel more confident like you've learned pandas, and initially you're just looking at it and typing, but then with time, the notebook on the right goes away, and then you can simply type by looking things up online or by looking at the documentation or just from memory once you've done it enough times. Okay, so do this analysis for your country. Try to first create that data set for your country from the raw data, and I'll post a link to the raw data as well. We'll post it in the lecture forum. So, and that should be a good place for you to just get started doing some more analysis. So what to do next? Try out the notebooks yourself. Try it with a different data set for your country. Maybe you can even share your Jupyter notebook with us. Share it on Twitter, and we would love to tweet it out. You can also share it on. You can also write a blog post and let us know the link, and we will share the link via our official social media account. So we are looking to share 4 or 5 interesting links every day. So do tweet at us. You can then now solve and submit assignments 2 and 3. If you're not done with assignment 1, you have a few more hours to do that, and you can submit assignment 2 and 3 as well. You can ask and answer questions on the forum. So any questions related to the lecture, questions related to the assignment. So just go to the forum, or just go to the forum for the lecture or the assignment. So here is the lecture. So it seems like there are a lot of questions here already, and we will answer them in our office hours on Wednesday, 9 p.m. Indian Standard Time. So you can ask questions, but every question that you ask, also try to answer at least one question, because that is how we are going to answer all the questions when we help each other out. And answering questions is a great way to learn as well. And if you have questions about the assignment, you can ask them on the assignment thread and help each other out. You can ask for hints. You can describe your approach in simple words. You can link to documentation, but we request you not to share the full working code on the forum. That's probably not a good idea, because then you're taking away the opportunity for somebody else to learn on their own. So you can describe your approach in as much detail as possible. You can point out issues in things that people are sharing, and you can link to documentation, but please don't share the full working code. Okay. And then finally, try to join a study group. So the enrollment is still open. So do join a study group, and you can learn together with your friends, or you can learn from other people from your city or from your time zone, and you can help each other out with the assignments. Maybe if you do some analysis for your country, you can use that. You can discuss that with them. And join us for the office hours on Wednesdays, 9 to 10 p.m. Indian Standard Time. This is on our YouTube channel. So you just go to youtube.com/jovianml and you subscribe, and we will send you a notification when we have the next video up for the office hours. We will do a week walkthrough of the assignment, which we've done here, and we will also answer the questions posted on the forum. And I also want to just tell you briefly about the Jovian.ml Data Science Mentorship Program. So this is an exclusive, limited and paid mentorship program where you can get one-on-one guidance from industry experts on how to advance your data science career. So this is not a part of the course. This is just a program that we have launched recently, and we filled out the seats for this month, but you can still join the waitlist by going to jovian.ml/mentorship. And that's it for today's lectures. I'll see you in the forums. I hope you found this useful. Do try out pandas either with the COVID data or with any data set online. You can go on Kaggle, you can go on Google dataset search, you can search online for data sets, and just the more you try, the more you experiment, the more you will learn. And I will see you in the forums, and we will meet next week live for the next lecture. Thank you and good night.